Hey everybody, Ethan here from WordTech, back with another video, and today I wanted to talk about something a little bit interesting. So I made a video recently, it's like 30 minutes, you can go check it out if you want, talking about some things that I would like to see Ubiquiti add to their firewall lineup. And one of the features that I talked about in there, I talked about IPSec stuff quite a bit, and one of the features was being able to bind an IPSec tunnel to an internal interface so that you can do internal performance testing, or maybe you have a reason to encrypt that traffic internally or something along those lines, and it can't be done. However, there is a roundabout way to get this working, and I figured it was worth making a video on just to talk about it and kind of show you what that looks like. So I decided I would go ahead and put this together and kind of walk you through it in both Unifi, as well as I'm using pfSense on the other end of the IPsec tunnel, and then I have a VM set up all in XCP-ng to show you some like iPerf performance testing between the two and stuff like that. So kind of interesting, and I figured it was worth talking about. I don't know how long this video is going to be, but it's one that I wanted to put together. I did some validation with this last night, and it seems like a good time to go ahead and give this a shot. All right, so the first thing that I actually have to do here is set up a third-party gateway subnet VLAN in Ubiquiti's equipment. So I'm going to go over to the Networks tab, and the reason we're doing this is I basically need to make the Ubiquiti Dream Machine route into another VLAN on a WAN interface. So I'll get to that here in a second of what that looks like, but basically you just need a VLAN set up that you're going to use, and it needs to be set as a third-party gateway so that the Dream Machine isn't trying to assign that same IP address and subnet to one of its internal interfaces that it's like going to respond to traffic and do routing based on and stuff. So it needs to be a VLAN only. Now, since we're testing this as IPsec performance on effectively a layer 2 network with VLAN tagging, we don't need to configure like a default gateway and stuff like that in order for it to work, because it's all going to be on the same actual subnet. So I will do a create new. So I'll do a create new, and we will do third-party gateway, and I'm just going to call this IPsec testing. And then I'm going to set the VLAN to 88 because I know that's one I am not using. That's going to go out and provision the 88 VLAN on all of the switch ports that I need it to be on. I have all of that set up already, but there's a key part to the switch port that I'll get to in a moment. But first I'm going to show you setting up the WAN side, and then I'll also walk through setting it up in XCP-ng, and it'd be similar if you were doing this in Proxmox or some other hypervisor in terms of the actual setup. You're basically setting up an internal only network that's just a VLAN, and then, you know, we're going to be doing, basically we're doing all layer 2 here, but in order to test, you know, layer 3 routing performance and IPsec performance specifically. So layer 2 is kind of the better place because you're removing additional routers from that. So you're not going to have a result of something being slowed down because of additional hops on the network or something like that. So the next thing is going to the Internet tab. And then in here, we're going to create a new ISP. And this one I'm also just going to call IPsec testing. And I'm going to assign this, in my case, to port 8. And it's very important that we know what port we're applying this to, because you don't want this port plugged in until you get all the VLANs and other stuff configured correctly. If you were to plug this in right now, you could end up with a network loop. So I figured it was worth just mentioning that. And then you don't need to set up any of the ISP speeds or anything like that. You don't need to set up the VLAN ID. So what I'm actually going to be doing is using the switch port that will plug into port 8 on the Dream Machine. That port will handle the tagging, so the Dream Machine has no idea that this is even being tagged on the WAN side. And then I will go into static configuration, and then I already know the subnet I'm going to be using for this. So it's going to be 192.168.20, and then I'm going to be setting this to .10. It requires a gateway IP, which is slightly annoying because you might want to set up a layer 2 network. So I just set that to the, what would be the default gateway for that network. Doesn't really matter because this should all be handled in layer 2 via ARP requests. So it shouldn't need a default gateway for anything. Now we can leave other stuff on auto. I'm not using IPv6 for this, so we're going to leave that disabled. And the important thing is I also have my WAN settings need to be set to failover, which will show up when I add this WAN in here. And also it shouldn't, I'm going to create an individual WAN SLA for this that's going to ping the pfSense box, because otherwise it'll probably keep this administratively down. So I think we're good here. Watch me just take my network down by accident because it switches to load balancing by default. That'll be a great thing to complain about in the video if that happens. Let's see here. I have that port disabled, so I'm pretty sure it's going to be okay. It is set up for failover only, and this is the important thing here that I was going to note, is you want it to be set up for failover only. You don't want it to try and load balance across this, because we're not actually going to pass any WAN traffic across this. That's like, we don't want that to happen. Like, I have other people using the network right now. We definitely don't want that to happen. So, anyway, and forgive me, there's probably a big blur box up here because I'm trying to blur out my public IP. Not that that'll probably change by the time this video even goes live, but out of a bunch of caution, I tend to do stuff like that. So sorry if there's a blur box there. Anyway, so we've got this set in failover mode. Now it will do an SLA of auto, and the problem with that is it's going to try to ping out across this and consider it down because it's set as having to ping like external IP addresses. So what I do is I go down here and I'm going to create a new SLA, which is also taking a while to load. I don't know why things are being kind of slow on the Dream Machine. Anyway, so I'm just going to call this IPSec testing as well so that we have that in here. And what I'm going to do is I'm actually going to set this to ping the pfSense IP address because I know that that's going to respond to ping once I get it booted up. It's actually turned off right now, but I will set that as the thing to ping to consider this administratively up. So we're going to click add. That's going to add that SLA, and then we need to assign that SLA to this secondary WAN interface. But it's still physically disconnected and we're still on failover only, and it's still set up as the backup. So that's very important. So when I go plug this in, this is not actually going to be an interface that's in use. It will not take my network down. It didn't last night either. I don't know what was up with adding a WAN connection causing me to lose connectivity to the Dream Machine. I didn't lose actual internet or network access anywhere, so it seems relatively non-destructive, but I would be aware of that if you're testing this in an environment where people maybe are relying on it a little bit and you need to test this for whatever reason. And I guess I'll go back to the, kind of the whole reason I wanted to do this was to do performance testing of IPsec from the Dream Machine's perspective. And it's only capable of a few hundred megabit across IPsec with good security settings, AES 256, DH group 21. I'll show all that in a minute. But that was the reason I wanted to do this. And so this was another example of like, how do you test this in a lab environment when you are also trying to use the firewall in a more like real world scenario environment. So I don't just mean this from the perspective of like, I actually use this firewall, but I actually mean from the perspective of if I was testing this and trying to do a review of this firewall, like performance, like say it just came out and I was trying to do a performance review of this firewall, for me, I need that firewall to be doing a lot more than just your raw like IPsec stuff, right? Like if it was just set up where the WAN interface was connected to a layer 2 and you had another box and you were just doing IPsec testing and pushing traffic across it, like that's great and all, sure, whatever, but that's not realistic based on something that should also be keeping track of flows, handling a large number of Unifi devices, handling a large number of clients, a lot of bandwidth going on. So I wanted to see more of like a real world performance metric as well, not just direct lab testing. And so this is why I decided to try and go down this rabbit hole of figuring out the best way to do this. Anyway, so we've got that configured now, and that port is still technically disabled on the Dream Machine, which I'll show in a second. But first, I need to go to my Unifi devices, and in this case, I'm going to open up my Switch Pro 24 and go to Port Manager. And then within the Port Manager, I'm going to use port 24 for the testing here. In fact, you can see I recently had the Dream Machine plugged into it. It was able to identify itself. I'm going to set this port to active, but what's really important here is you need to have block all VLANs on and then use the IPsec testing VLAN that I set up in my case here, which is VLAN 88. That needs to be set up, and you want this to be block all because you don't want to create a network loop or do anything else weird. And this is already weird because we're using a switch being controlled by the Dream Machine to handle the testing and trick the Dream Machine into thinking it has another LAN interface. So we're intentionally creating a physical network loop, technically speaking. So it's important to make sure you set this up ahead of time. So I'm going to apply these changes, and then I'm actually going to wait and go. I'll configure the Dream Machine is what I'll do while we're waiting. You don't want to go plug it in immediately. You want to make sure that VLAN actually, that port actually provisions. So you don't want to just run over there and plug it in, which is what I'm going to do here in a minute. Then I go to port 8, which is a WAN, but we have the ability to leave WAN ports disabled. So that was the other thing that I did at the beginning of this, is I disabled this port. I keep all my ports disabled if they're not in use, but this port was disabled, which means even if it didn't do the proper thing in the internet settings where it added the secondary WAN as a failover only WAN. Even if that was broken and it tried to switch it to load balancing by default, the port's disabled, so it should have considered it administratively down. So that's another reason to leave the port disabled and leave the cable unplugged, because it shouldn't be trying to route across that WAN, and you don't want it to do that until you have everything configured. So I'll switch this over to active. We can just leave auto negotiation as fine and do apply changes. That port should be active pretty quick here. And so what I'm going to do is get up and I'm going to go over there and I'm going to physically plug port 8 from the Dream Machine into port 24 on the Switch Pro 24. Then we're going to go ahead and add this to XCP-ng and boot up pfSense, which should start responding to pings, and that should show the internet as live. So like if I go over here to internet again, this here uptime should start to eventually go up once that cable's plugged in and pfSense is booted up so that it can respond to the pings that pfSense has on that interface. Okay, so that port is up. You can see that it shows a link light here, but it still shows the uptime at 0% because of course it can't ping, so it's not, the WAN SLA that's set up for it is not in use. Love that they added this, by the way. So cool that you can set up multiple things to ping and stuff. I love that. Anyway, this is great. So first we're gonna go over to XCP-ng, and actually I'm gonna open it up in yet another tab. And what we're going to do is configure VLAN 88 on one of the pools. So in this case, mine's all on my first pool. So I'm going to go over here and go to network, add network, and we have to select a physical interface. I'm going to call it IPSec testing as well. And then we have to set the VLAN to 88, create network. So that's going to be added to XCP-ng. And so what this means is the ping traffic that the Unifi Dream Machine Pro should be doing right now to that 192.168.20.20 address should end up routing, and not routing, but you know, it's running over a layer 2 network over into XCP-ng. So the next thing to do is I'm going to go over to pfSense and I'm going to add I have a pfSense VM already built in here, and we're going to add a network device, and it's going to be on the IPSec testing here. So I'm going to click create. And while that's booting, I'm also going to go over to my test VM, which is set up for a different network right now. This is just an Ubuntu VM I have running. I'm going to switch it over to IPSec testing as well. So this means that this VM is going to be trying to connect to pfSense. Basically, it's going to use pfSense as its DHCP server. And pfSense is one of the things that makes this easier because you don't have to do any trickery in pfSense. You can just tell it, hey, listen for an IPSec tunnel on your LAN interface, and it'll just do it, which is fantastic. But anyway, I'm gonna log in here. Okay, so we're signed into pfSense. You can see I'm accessing it on the 15.1 network, so we're on the subnet behind pfSense, right? So we're not on that 168.20 subnet, so we know for sure that we're segmented in that sense. So now that this is set up, we basically just need to configure the VPN between the Dream Machine and pfSense, and then we can do some iPerf testing, and there's a couple of firewall rule things that need to be added too. So I will start with the VPN configuration. So we will go into the Dream Machine, we will go to VPN, we will go to site-to-site VPN, create new, and in here it's going to be IPSec. I'm going to call this IPSec testing as well. I'm going to set the pre-shared key to, can you have a short pre-shared key? It's been a minute since I've looked into that. Let's see if it'll behave or not. And then I'm going to select the local IP, which is WAN 2, and this is basically selecting what interface it binds to. I don't know if it binds to all WAN interfaces and it just listens for this IP or not. I'm actually not sure about that, so something to be aware of, but you can't bind it, as you can see, to a local IP address, a local interface, which is what frustrates me about this. I'm going to do policy-based in this case. The local network that's going to be available is actually going to be the LAN that my machine's on. So I'm just going to select that LAN. The remote subnet is that 192.168.15.0/24 subnet. And then we're going to set up manual IPSec, which you always should. I would never trust an auto IPSec tunnel under any circumstances. You should always, this is really in a public environment, you should be configuring these yourself, and you should know what these settings mean. If you want to see a video, at some point I can put together a video that goes over IPSec in depth. I've done some pretty crazy IPSec builds for environments that require really high speed acceleration and stuff. So anyway, I think that could be a fun conversation to have, but the point is you do want to actually adjust these settings to definitely use IKV2, not V1. V1's easy to misconfigure. So if you go here, I'm going to set the encryption to AES-256, SHA-512, DH group 21. You probably shouldn't use any other DH group if I'm honest. And I'm going to set that for both phase 1 and phase 2 just to make things easy. And then the rest of these settings can be left to default. And then I forgot to put in the remote IP. Whoops. This is that 20.20, so same subnet there. So this VPN here, we've got this configured, and as long as it does let me set a key that short, it's, like I said, been a minute since I tried a manual key. Normally you want to use the pre-shared key. You want to use a really well-generated one, generated by either pfSense or by whatever firewall you're using. I'm just using a shitty one because this is local only. So we're going to add a phase 1. pfSense separates the phase 1 and phase 2 into separate configurations entirely. This is another area that pfSense is just, when it comes to VPNs, it's just better than Ubiquiti on all fronts, including performance. But anyway, so we'll call this IPSec test, and then this is also going to be IPv2. I'm going to bind it to the IPSec test interface, which again is so nice that you can do that. Then we're going to put in the IP address that I'm using for the WAN interface on the Dream Machine here. So you got my identifier, peer identifier. I'm going to leave those as default. I'm going to put in my pre-shared key, which you should always obviously hide. You can also generate a pre-shared key if you want to use a generated one instead, which again you should. We're going to leave standard AES because Ubiquiti does not support Gallios counter mode, so we're not going to use that even though it's more performant. We're going to set it to 256 bits, SHA-512, DH group 21. Then we can leave the rest of this stuff all here as default. That's totally fine in this case. I would probably configure some things in here if I was doing a real VPN for something, but we're just doing basic performance testing. We don't need anything special set up, so leave that as default. And then before I apply, I'm going to add a phase 2 to this, which I'm also going to call IPSec test. I'm going to say P2, so I can't remember if there's name conflicts between P1 and P2. We're going to select the subnet, the local network, in this case is that LAN, which is the 192.168.15.0/24, so we don't need to manually type it in because pfSense lets us just select the interface there. And then the remote network, we are going to set, this is not the remote IP address of the Unifi Dream Machine, but the remote network that we're trying to access, which is actually going to be the network for my local machine. All right, in here, it's ESP, so we're going to leave that. We're going to uncheck ASGCM. We're going to do 256 bits here, SHA-512, like, this is all I'm just going through. And the rest of this can be default. So this is just like setting up any other IPsec tunnel. Okay, so I've configured the IPsec tunnel here on pfSense. I may have cut out a big section of the video because this is getting kind of ridiculously long, if I'm honest, for the tutorial that I'm trying to do. And configuring IPsec tunnels between the two devices is just like any other IPsec video or any other IPsec configuration. So I might make a separate video on that at some point just to show you what I like to do, like a deeper dive into IPsec. But regardless, I configured the tunnel on both sides. So we have a tunnel configured here. And then if I go over to status here, oops, wrong one, status, this is going to show established already. So we have that VPN established, which is important. And you can see that P2 is also connected. So we know this VPN is up. You can also view that in the Dream Machine over here. But this is where I get a little bit annoyed with Ubiquiti, as they should have better IPsec information here, in my opinion. This is too slow to update. It needs to be something that I can manually refresh easier, and it also needs to update faster because it'll sit here connecting. If I refresh, maybe that'll fix it, maybe not. Okay, now it's established. But this is the kind of thing that I would like to see better logging data around this. Okay, so anyway, we know the VPN's up, so the next thing we're going to configure is some firewall rules here, and I will show this, even if I did end up cutting out the IPsec section, because that's pretty standard. I'll show the firewall rules, because this is not exactly the most standard. So, over on rules, since this is a lab environment, I'm actually going to be doing some pretty open rules. So if I go over to the IPsec side here, so here we have an any rule, because this is all internal. So I'm just any-ing this to make it easy. You would want to make sure you allow whatever traffic you're trying to do for this. Now, if this is just for performance testing like I'm doing, any is fine, as long as nothing's publicly exposed. And then on the LAN side, I also have an any. So we're trying to make this really, really simple here on that front, but I do need to allow the traffic from my box that I'm actually recording this on right now. I need to allow that traffic to run across the firewall of the Dream Machine before it's able to get across the IPsec tunnel. Now, since we did a policy-based route, we don't need to configure static routes in the Dream Machine. It's going to configure that in the IPsec settings. When you configure that policy route, it now knows that this 192.168.15.0/24 network is available at that tunnel. And so if I try to connect to something over there, that's the route it's going to take, but only once it's allowed through the firewall. Okay, so I'm over here, and in this case, since it's running over a VPN, we need to use the internal to VPN zone on the zone-based firewall. And then you can see I have my normal rules that I put in here. So I'm going to create a policy, and this is also going to be testing IPSec, just like everything else has been. And we're going to select, in my case, I'm actually going to select a specific IP address that I have set for my desktop here. And then I'm going to do allow any actually in this case, because again, we're doing this as internal testing. And so I'm not concerned about allowing any traffic between these different zones. And then what I actually will do is set an IP address and set that 192.168, just so I'm not opening it up like, way too much. So I'm setting that in here, that 192.168.15.0/24. And then we're going to allow anything across the board, and I'm going to click allow. Now, in my case, of course, I have a custom block all rule, and Ubiquiti always adds the rules to the bottom, which is the safer thing to do. Sometimes I wish you could add to the top by hand, but bottom's generally safer. So now I need to reorder this and put it up here so that it's available here. And then that's going to allow the traffic. So we got the policy route set up. We got the firewall set up. Now, again, we didn't have to manually create a policy route because it's a policy-based IPsec tunnel. That policy routing is basically done for us. We don't have to think about it. So next, I'm going to go over here. I have iperf installed on the Ubuntu box. So I'm just going to set iperf to listen on that machine. So that's iperf 3-S. Once you have it installed, then it's going to be listening on the default port. Okay, so here we have PowerShell open. I also have iperf 3 installed on my local workstation. So all I have to do is, you can even see I have the command in here already, iperf 3-C 192.168.15. Oh yeah, I need to grab the IP address actually of the VM, which is in the background here. Hold on. And now I'm not even going to set the other parameters right now. I'm just going to try and connect to it. And you can see here we are routing a single TCP stream with iperf 3, and this is going from the from my device to the Ubuntu virtual machine, because we're not doing the -R, which would mean the server transmits to us. So this is going to be uploading, basically. This is like practically testing uploading speed. Now you'll see I got 232 megabits per second. There is going to be, a little bit of overhead from things here and there. We're going through quite a few switches. We're not going through any routing hops other than the two firewalls themselves. And we are routing over the VPN, but I just think it's important to note that, there's a little bit of additional stuff. So like, again, if this was a completely raw environment, the performance might be a bit better, but the point was to show this kind of in a real world scenario. And so if you were curious how AES 256 performs in specific on these firewalls on the Dream Machine Pro, this is what you're looking at here. Now, the thing is, I've done HTOP testing to validate the CPU performance of the Dream Machine when it is under a heavy IPsec load. And it does get up there, like almost maxes it out once you do this. So this is a speed limit that we're seeing on the Dream Machine. I've validated in other lab cases, which I'm not going to do in this video because, again, this is already at least 20 minutes. But I've validated that pfSense will perform higher than this. My pfSense VMs will, even without additional acceleration in place. In this particular case, this VM is assigned 12 CPU cores and 8 gigs of RAM, so it's got quite a bit of hardware behind it. It's a Threadripper 1950X and pretty fast RAM, so all SSDs and everything, so it's pretty beefy. And what we're seeing here is really the limits of the Dream Machine, which 232 megabits a second isn't like terrible. It's just that it doesn't. This is kind of the thing I've talked about in some of the other Ubiquiti videos that I've made. Their IPsec performance and just their VPN performance in general leaves a lot on the table for the class of device that it's attempting to market itself as. And that's maybe fine, because let's be honest, like most environments actually don't need super high performance VPNs. They really don't. So I don't necessarily blame them for not prioritizing that, although it would be really nice to see. But it's just when you see a firewall that can route 10 gig, but then, here we're getting like, let me do like, how about 8 streams just to give it the benefit of the doubt, we're getting 300 meg, right? So 10 gig to 300 meg for VPNs, like that's a pretty steep drop off in comparison to like my Netgate 6100, which real world performance iPerf performance, I should use that since we're using iPerf here. So best case scenario performance of using iPerf 3 on that, you're looking at like 1.5 gigabit over IPsec with the right acceleration stuff enabled on it, which comes on the hardware. Meanwhile, that firewall can only route like LAN to WAN like 3.5 gig and LAN to LAN like 4 gig. So it's way slower at the routing level. And many people would argue that, oh yeah, well, I mean, if you're buying a firewall, in most cases, you're going to care more about the routing performance than the VPN performance. And that's true for a lot of scenarios. Like 300 megs is enough for a lot of like site-to-site VPNs and stuff. And of course, WireGuard's even faster on this. But The point is that it doesn't exactly match the class of device, and I hope we see that start to change. We've got the Enterprise Firewall Core and the Dream Machine Beast that are available now, but I don't think anybody's done enough testing on those yet. I might get a Beast in at some point to test, and then I could test its performance against my Netgate 6100, which again I know can do at least 1.5 gig across IPsec, so we get at least some performance metrics to see what that looks like. But as you can see here, we're only getting like 300 megs, which is not amazing, but I guess not bad given the price. You know, a dollar per megabit about for the price of the firewall over IPsec. But anyway, I just wanted to put this together because it was kind of a fun brain twister thing for me. I spent a while on this last night to be like, how can I trick this thing so that I can do a LAN-based IPsec tunnel so that I can test the performance of it and see what it's like, because we've seen some benchmarks out there, but not enough in my opinion. So I wanted to kind of benchmark it, and I'm not planning on like spreadsheeting this and building pretty graphs or anything for this video here. I don't think that's necessary, and maybe I'll cut this end portion out just to talk about it. But regardless, I thought this was an interesting one to talk about. So thank you everybody for watching. Let me know if you have any questions or if you want to see other interesting content around firewalls and networks or virtualization or whatever. I'm kind of just throwing whatever out there now. I have recently had some changes in life that have helped me have a little more mental capacity to work on videos, so the hope is to start rolling these out at a little bit of a faster pace.